So we're going to go over review problems you can expect to see on the Module 4 test. So we're going to start off with question 1. We're going to use the rational function f of x equals x minus 6 over x squared minus 7x plus 6 to answer some questions. So the first thing we want to know is what values should be excluded from the domain. So in order to figure out what values should be excluded from the domain, we find when the denominator equals 0. So we want to find when x squared minus 7x plus 6 is going to equal 0. So if we factor, we look for the numbers that multiply to 6 but add to negative 7, which would be negative 6 and negative 1. So it factors as x minus 6 times x minus 1. So for our domain, x cannot equal 1 or 6, since those values would make it 0. So next we want to list all of the wholes and vertical asymptotes of our function. So let's go ahead and rewrite our function in with our factored denominator. So x minus 6 over x minus 6 times x minus 1. We have a common factor that cancels out of the numerator and denominator to give us 1 over x minus 1, which means we do have a whole, and it's at the x value that makes what cancels 0, so that would be at x equals 6, and our vertical asymptote is going to be at the x value remaining in our denominator to make it 0, which would be x equals 1. Next, we want to list any horizontal or slant asymptotes. So that comes from the degree of our original function in the numerator and denominator. So our original function, x minus 6 over x squared minus 7x plus 6. The degree of the numerator is 1. The degree of the denominator is 2. So when the degree of the numerator is less than the degree of the denominator, it's a horizontal asymptote. Specifically the equation y equals 0. Okay. Next, we want to list any x or y intercepts. So if we start with x-intercepts, those come from when the numerator equals 0. So our numerator is x minus 6, so we want to find it when it will equal 0, which is when x equals 6. So our x-intercept is going to be at 6, 0. Our y-intercept comes from when we evaluate the function for 0, which leaves us with the constants in our numerator and denominator being divided. So in this case, that would be negative 6 from the numerator divided by 6 in our denominator, which becomes negative 1. So that means we have a y-intercept at 0, negative 1. Now we want to use all of this information to sketch a graph of our function. So we're going to start with our horizontal asymptote and our vertical asymptote. So our horizontal is the equation y equals 0, which is our x-axis. And our vertical asymptote is x equals 1. Now if we graph our x-intercept and our y-intercept, our y-intercept is 0, negative 1, and our x-intercept, which is 6, 0, which happens to be where our whole is at, would actually be a whole at 6, 0. So now we can use that to graph our function. So using Desmos is kind of like as a guide, we get the following sketch of our rational function. So next we're looking at what the slant asymptote for our function f of x equals x cubed minus 5x squared plus 6x minus 8 divided by x squared plus 4 is. So to find a slant asymptote, we do long division. So x squared plus 4 on the outside, and underneath x cubed minus 5x squared plus 6x minus 8. So we divide x cubed by x squared and we get x. And then we multiply it by what we're dividing by and we get x cubed plus 4x in parentheses with our subtraction out front. X cubed minus x cubed cancels. Negative 5x squared, and there's no x squared term to subtract from it, so it's going to stay negative 5x squared. We have 6x minus 4x, which is going to give us 2x, and then we bring down the minus 8. Next, we take negative 5x squared and divide it by x squared, and we get negative 5. Multiply it by what we're dividing by, we get negative 5x squared minus 20. Put in parentheses, subtract. Negative 5x squared minus a negative 5x squared cancels. There's nothing to subtract from the 2x, so it comes down, and then negative 8 minus a negative 20 changes to addition, and we get positive 12. We can't take 2x plus 12 and divide it by x squared, so we are done, and our slant asymptote is the equation y equals x minus 5. Next, we're going to solve some rational and radical equations. So looking at our first equation, we have x minus 4 over 2 equals x plus 1 over 5. So in order to solve our equation, we want to identify the LCD. In this case, our LCD is going to be a number. Our least common denominator is going to be 10. So we're going to take x minus 4, multiply it by 10, equals x plus 1 times 10. And instead of canceling out factors that occur, we're going to go ahead and divide. So 10 divided by 2 is 5. So we get 5 times x minus 4 equals, and then 10 divided by 5 is 2 times x plus 1. So now we're going to distribute. We get 5x minus 20 equals 2x plus 2. And now we work on solving for x. So we're going to subtract 2x from both sides. We get 3x minus 20 equals 2. We're going to add 20 to both sides. We get 3x equals 22. Divide by 3, and 22 divided by 3 is not a whole number, so our solution is x equals 22 over 3. And since the denominators of both of our terms are numbers, there is no value that's going to make it 0, which means x equals 22/3 is not an extraneous solution. Our second example, 2x over x plus 3 over x minus 6 equals 27 over x squared minus 5x minus 18. So before, I'm actually going to go ahead and change the denominator of our function to x squared minus 3x minus 18. So before we identify our LCD, we want to factor our denominator so we're looking for what multiplies to negative 18 but adds to negative 3, which is going to be negative 6 and positive 3. So factors is x minus 6, x plus 3. So our LCD is going to be x plus 3 times x minus 6. So now we multiply our numerators by our LCD. So we get 2x times x plus 3 times x minus 6 over x plus 3, plus 3 times x plus 3 times x minus 6 over x minus 6 equals 27 times x plus 3 times x minus 6 over, and then I'm going to write it, the denominator in its factored form, x minus 6 times x plus 3. So now we're going to start canceling factors that appear in the numerator and denominator. So we can cancel an x plus 3 and x minus 6, and then x plus 3 and x minus 6. So we're left with 2x times x minus 6 plus 3 times x plus 3 equals 27. Distributing, we get 2x squared minus 12x plus 3x plus 9 equals 27. Combining like terms, we get 2x squared minus 9x plus 9 equals 27. In order to solve a quadratic, it must be set equal to 0, so we're going to subtract 27 from both sides. We get 2x squared minus 9x, and then 9 minus 27 is negative 18 equals 0. So now to find our solutions, we want to factor 2x squared minus 9x minus 18. So using the method we've used previously, I'm looking for multiplies to 2 times 18, negative 18, which is negative 36, but adds to negative 9. It's going to be negative 12 and 3. Divide both by our leading coefficient of 2, and negative 12 over 2 is negative 6. So it's going to factor as x minus 6 times 2x plus 3, which means we have the solutions x equals 6 and x equals negative 3/2. Now we always have to check to see if either of these numbers are going to make our denominator 0, and x equals 6 will make 2 of our denominator 0, which means that it is an extraneous solution, and our only solution is x equals negative 3/2. Next, we're going to solve a radical equation. So we have the square root of 6x plus 1 equals x plus 1. Our radical is isolated, so we're going to go ahead and raise each side to a power, and in this case, that's going to be squared. So we end up with 6x plus 1 equals, and then for here we have x plus 1 times x plus 1, which when distributed gives us x squared plus x plus 1. So combining like terms, we get 6x plus 1 equals x squared plus 2x plus 1. So because we do have a squared term, we want to have our equation equal to 0. So that means subtracting 6x and 1 from both sides. So we get 0 equals x squared minus 4x. And in order to factor x squared minus 4x, we factor out a GCF of x, and we're left with x minus 4 in parentheses, which means we have the possible solutions of x equals 0 and x equals 4. Now, just with rational equations, we always have to check our solutions for radical equations as well. So plugging back into our original equation, we have the square root of 6 times 0 plus 1 equals 0 plus 1. 6 times 0 is 0, so we get the square root of 0 plus 1 equals 1. 0 plus 1 is 1, so we get square root of 1 equals 1. The square root of 1 is 1. We do get a true statement of 1 equals 1. So x equals 0 is the solution. Now we need to check to see if 4 is the solution. So 6 times 4 plus 1 underneath the square root equals 4 plus 1. 6 times 4 is 24, so we get the square root of 24 plus 1 equals 5. 24 plus 1 is 25, so we're at the square root of 25 equals 5, and 5 does equal 5. So another true statement, which means both x equals 0 and x equals 4 are solutions to our radical equation. Next example, we have the square root of x minus 1 equals the square root of x minus 3. So before we can raise each side to a power, we have to isolate our radical. And in this case, that instead of subtracting the square root of, I'm going to subtract the square root of x from both sides. So we get negative 1 equals the square root of x minus 3 minus the square root of x. Now we're going to square each side. Negative 1 squared is 1. We get the square root of x minus 3 minus the square root of x times the square root of x minus 3 minus the square root of x. So now we work on distributing. We get the square root of x minus 3 squared minus the square root of x times x minus 3 minus the square root of x times x minus 3 plus the square root of x squared. Canceling out square roots, distributing and combining like terms, we get x minus 3 minus 2 square root x squared minus 3x plus x, which gives us 2x minus 3 minus 2 square root x squared minus 3x. To isolate, since we still have a radical, we need to isolate our radical again. So we're going to subtract 2x and add 3 to both sides. So we get negative 2x plus 4 equals negative 2 square root x squared minus 3x. To finish isolating our radical, we're going to divide by negative 2. So we get x minus 2 equals the square root of x squared minus 3x. Now we're going to square both sides again. So our left side is x minus 2 times x minus 2, which is going to become x squared minus 2x plus 4 equals x squared minus 3x. Combining like terms, we get x squared minus 4x plus 4 equals x squared minus 3x. If we subtract x squared from both sides, we get negative 4x plus 4 equals negative 3x. Then to finish solving for x, we're going to add 4x to both sides, and we get that x equals 4. We do need to check our solution with our original radical equation, which was the square root of x minus 1 equals the square root of x minus 3. So plugging in 4, we get the square root of 4 minus 1 equals the square root of 4 minus 3. Square root of 4 is 2, so you end up with 2 minus 1 equals the square root, and then 4 minus 3 is 1. 2 minus 1 is 1. The square root of 1 is 1. 1 does equal 1, so x equals 4 is a solution. So last part, given our function f of x equals the square root of 3x minus 4 plus 1, we want to answer the following questions. First, we want to know what the domain of the function is. So domains of square root functions, you have to take what's underneath the square root, so 3x minus 4, and it has to be greater than or equal to 0, since we can't have negatives underneath the square root. So solving our inequality, we add 4. We get 3x is greater than or equal to 4. Then we divide by 3. And we get that x has to be greater than or equal to 4/3. And we always like to write the domain in interval notation. So our domain is 4/3 to infinity. Next, we want to know what the range is. So our range comes from the smallest value possible in our domain. So we need to evaluate our function at 4/3. So the square root of 3 times 4/3 minus 4 plus 1. 3 times 4/3 is 4, so we get square root of 4 minus 4 plus 1. 4 minus 4 is 0, so the square root of 0 plus 1. The square root of 0 is 0. So our range is going to be from 1 to infinity. Next, we want to make a table of points that would lie on the graph, and we want to list at least 3 points. So when we create our table of x and y values, I'm going to start with 4/3. Since it's the smallest value possible in our domain, that's where I want to start. Now I just have to pick 2 other x values greater than 4/3. And I'm going to pick 2 and 4. Now we already evaluated our function for 4/3 and found the y value to be 1. Off the side here, I'm going to evaluate it for 2. So we have 3 times 2 minus 4 plus 1. 3 times 2 is 6. 6 minus 4 is 2. And here's where I'm going to approximate. The square root of 2 is about 1.4. So we add 1 to it, we get about 2.4. Now if I evaluate for 4, 3 times 4 minus 4, then plus 1. 3 times 4 is 12. 12 minus 4 is 8. And again, we're going to approximate. The square root of 8 is about 2.8, and we add 1 to it, we get about 3.8. And you can pick any 2 x values you want, as long as they fall within our domain of values greater than or equal to 4/3. So using these 3 points, I can now get an idea of what my graph is going to look like. So we're going to start with the 4/3 1, and 4/3 is a little bit past 1. So about 1, a little bit past 1, and then a y value of 1 is where we're going to start. At 2, we have about 2.4. And then at 4, we have a value of about 3.8. And based on these values, we can get a sketch of our function. It's always good to include the minimum point as one of your 3 points that you graph, so you know where to stop your square root function, because I know nothing is going to be, this 4/3 1 is the smallest value I can have, so that's going to be my starting point.